In construction, detecting something is not enough. You need to prove it. AI is powerful. Nobody's arguing that. It can scan a point cloud in minutes, flag deviations across thousands of data points, classify objects faster than any human team. But here's what nobody talks about. AI doesn't know how certain it is. It finds patterns. It doesn't quantify reliability. And in construction, where a missed tolerance can mean rework, delay, or structural failure, a pattern without proof is just a guess. Detection is not certainty. Statistics is not exciting. Nobody puts it in a keynote headline. But it's what separates actionable results from expensive noise. Statistics defines confidence. It tells you, this measurement falls within an acceptable range with 95% probability. It translates raw data into decisions that hold up under scrutiny. Your client doesn't care about your algorithm. They care whether the slab is flat enough to tile. Statistics answers that question. AI alone doesn't. This is where construction actually operates. Tolerances. Not exact values, acceptable ranges. A floor slab doesn't need to be perfectly level. It needs to be level enough, within spec. And within spec is a statistical statement, not an AI output. A confidence interval tells you, given the data we have, there's a 95% chance the true value falls in this band. Green means within tolerance. Yellow means approaching the limit. Red means out. Every measurement on your site lives somewhere on that spectrum. The question is whether your tools can tell you where. Here's the real relationship. AI tells you what might be wrong. Statistics tells you if it actually matters. AI flags a deviation in a point cloud. But is that deviation noise from the scanner? Is it within acceptable limits? Is it significant enough to act on? Without statistics, you don't know. You're reacting to every alert, chasing every flag, burning hours on things that don't matter. Statistical filtering separates signal from noise. It lets you prioritize real issues and ignore false positives. That's not a nice to have. That's the difference between a functional workflow and chaos. AI and statistics solve different problems, and confusing them is where teams get into trouble. AI excels at recognition, object detection, classification, segmentation. It sees what's in the data. Statistics excels at validation, tolerances, confidence levels, uncertainty quantification. It tells you what the data means. You need both. AI without statistics gives you detection without trust. Statistics without AI gives you rigor without scale. The combination is where construction analytics actually works. Most teams fail not because they lack data. They fail because they can't trust it. Here's what happens. You deploy a scan-to-BIM comparison tool. AI generates a deviation report. 3,000 flags. Your QC team looks at it. Half are scanner noise. A quarter are within tolerance. Maybe 10% are real issues worth investigating. But the report doesn't tell you that. So your team treats every flag the same way. They investigate everything. Or worse, they ignore everything because the noise overwhelmed them. That's not a technology problem. That's a filtering problem. And noise kills adoption faster than anything else. To trust a result, a real, defensible, actionable result, you need 3 things. First, a clear tolerance definition. What's acceptable? What's not? This isn't an AI question. This is an engineering specification. Second, statistical confidence. Given your data, what's the probability this measurement is within that tolerance? Not a guess, a number. Third, clean, filtered output. The report your team sees should contain only what matters. No noise, no redundancy, no thousand flag dump. Tolerance plus confidence plus clarity. That's the formula. Anything less, and you're asking your team to make decisions on incomplete information. This is where both worlds come together. Scan to BIM. You capture site reality with a laser scanner. AI processes the point cloud, segments it, classifies elements, compares them against the design model. Then, statistics steps in. It quantifies deviations, flags only what exceeds tolerance, gives you confidence levels on every measurement. The output isn't a data dump, it's actionable intelligence. Structural validation, MEP checks, as-built verification, all with numbers you can defend. The goal is not data. Everyone has data. The goal is decisions you can defend. Raw data becomes filtered insights. Filtered insights become clear recommendations. Clear recommendations become actions. That pipeline, from measurement to decision, only works when both AI and statistics are in it. Remove either one, and the chain breaks. If your system uses AI without statistical validation, you're guessing. In construction, guessing is expensive.